So let's understand why error handling is required. Before going into that, we need to understand why errors occur. In order to just let's go in through a example. Imagine you are sitting at a desk and there are two lights in front of you, a green one and a red one, and you have given a simple instruction. Every time the green light turns on, you note down the time at the exact moment. Easy, right? So let's say the green light turns on and you note down the exact time when it light out glow the light glows. Also you have the other light, red light, but there are no instructions given when the red light glows. In such a condition, we as humans we have intuition. So even if the red light goes on, we don't do anything. We just simply we haven't have any instructions to do along. So we just simply watch it and ignore it. It's just we don't freeze in time. It just we just see it and chill. But computers, these are completely logic driven. Like they have to meet some condition, some parameter to go further. So if we give this exact simulation or exact condition of having two lights in front of the in like provided two lights and one is a green one, the other one is a red one, and when the green light goes on, it notes the time, and we haven't provided any instruction for the red one. But the condition in here is every time a light goes on, you have to do some action, but we haven't specified any action for the red one. So in this condition, it handles the green light as given perfectly. But the second the red light goes off, the computer just panics. It doesn't know because it's a logic driven device, doesn't know what to perform. So it enters an error state and completely halts everything because it doesn't know what the further action to be done. So in coding world, we call this as a crash or an error. And this is exactly why we need error handling. So going into more technical stuff, when things go wrong, error usually falls into two categories: known errors and unknown errors. So known errors are something we understand some this kind of an situation can come up. So we, the programmer who built the language, have provided will be providing us with some built-in exceptions. Every time an error happens, we perform an alternate action in that condition called exception. We just accept this. Okay, leave this and do this action. So for unknown errors, we can build custom exceptions or just throw this error and collect this error and make a generalized exception over there. So for say for built-in exceptions, we can have a zero division error or file not found error. Let's say mostly we be dealing with the file not found or null pointer error. In the memory address, we haven't saved anything and we are trying to access that empty memory for a value. Then it's an exception. It's an error state. In that case, we need to make an exception. Coming to the unknown errors, these are just weird specific situations unique to specific application or business logic. For this, we can create custom exceptions and handle them like the situation we faced, right? For the red light, what to do. So if you observe this simple Python code snippet, we be performing the riskier code. I mean, we we might assume that this might give an error. We just perform this action in the try block, and if any exception comes out of it, we'll be handling in the except block. So instead of going full panic mode and halting the program and exiting everything, we just have an alternate path that saves the day. So exception is just a backup plan. It's telling the computer, hey, just instead of completely crashing and being chaotic, do this instead. If everything goes smoothly, the computer runs the code, moves on. But if the red light passes and error pops up, the computer immediately jumps down to the except block, and this is your safe zone. And the uh, condition specified in this safe zone will be gracefully executed, and it will be done. So error handling is an action we tell the computer beforehand instead killing itself.